Okay, so this microphone a little closer. Today I wanted to talk about how to write tests for functions that read and write to files in Node.
Are you recording?
I am recording. Thank you for reminding me. That's what seemed like was pretty relevant to a lot of the questions I was hearing this week. Is this relevant to y'all? Yeah. All right. Let's get a little example going on here. Wow, this makes my prompt look terrible. Okay. So what should we do as like an example of something that needs to read and write files? Let's do like a log command. Cool. So the way I want this command to work, I'll put some examples in here, is we're just going to do /log, and then we'll do list, and this will print the log. Yeah. And then we'll do log amend something, and that will, let's do append 2Ps, and that will write to the log. Yeah? So just like a little simple fake logger. So I'm actually going to rename this to just log instead of log.js, and then I'm going to put a shebang at the top, user local, or what is it? User local bin, or no, it's user, why can't I think? User bin emb node. Yeah, there we go. So this tells the script at the top that whenever this file gets executed just on its own, that this is the actual program that should be executing it. We could just figure out where node is and come up here and just put that and be like very specific about the version of node that we want. But I'm running node version manager on this machine, so I'm going to use this little trick where there's an env command where you say env and then some command, and it will just run that command. So I don't actually have to give a specific path to node. I can just say whichever node, like whichever ls is in my path, run that. It's a little bit of a trick.
Is that one of the dot files you gave us?
Is what a dot file?
The env.
No, env is a Unix command.
Oh.
Yeah. You don't need that. This is a standard way to say, use this command, whichever one is configured for the shell that you're in, right? So this is going to run whatever node I have installed and configured in the terminal, right? If you're familiar with Node Version Manager, it allows you to run multiple versions of Node at the same time, and different terminals can be configured to use different versions of Node. So this will make sure that I'm using whatever version of Node is configured at the time. Cool. So now the other thing I need to do is chmod +x to give this log file execution rights. So if we ls-l log, you'll see that I now have like execution rights on this file. So I should be able to console log. It works just by doing that. So now it's an executable file. Yeah? Any questions about the shebang and the executable part of this? No? Okay, great. Cool. So the first thing we want to do is if we want to look at process argv bracket 2 is going to be our command. And we'll see if that log list versus log append something else. Cool. So I want to be able to pass in whatever I want after append and have that just be the log line. So instead of grabbing just the third argument, I'm actually going to slice from 3 and join with a space. So now I should get the rest of those things. So if we look at this as, let's look at this as an object. So my command is append, and my argument is this, whatever was after that in the arguments. Yeah? Yeah. Yeah, so argv is an array, and slice just takes the first 3 things off the front. It basically creates a new array that's just the 4th element and beyond. Yep. That's what slice 3 here is doing. And then I'm creating a string out of that array. Okay, cool. So let's see. What else we got? Okay, so now we want to implement these 2 commands. So we're going to say if the command is list, we'll do something. Else if the command is append, we'll do something. Else, we're just going to print the usage of this thing. And so that's a nice thing that commands do. If you like, you know, if I just call brew, or if I just call get, and I haven't given it a proper command, it's just going to print out this helpful little usage document. So I'm going to make my script do that too. So we'll just do, we'll take what I wrote up here, and we'll create a function that just prints this stuff. So console.log, backticks for multi-line. And we'll just say usage is log list, which is like, I don't know, print the log, and log append log line message, append a message to the log. Cool, so that's our little usage output. And let's see what I get if I just run log, or not log. Cool, so I got my little usage output. I still actually have this. We should get rid of that. So if I send in no command, or the command doesn't match, I get like a little helpful message there. I'm curious actually what the exit status of get is. Got it. So we also want to process.exit 1 because this command didn't do anything successfully, right? You can think of it as like failing, right? If I run this command and I want to make sure that it was successful, if it prints out this usage, it probably wasn't a successful usage of that command. So we're going to exit with this exit status 1, which says that we failed, basically.
Why do you have to do that?
Because of things like this. If I want to do like, let's say I want to do several commands in a row in the shell. So let's say I want to say echo foo and echo bar, you know, and echo whatever, right? These and say do the next thing only if the previous thing was successful. Don't get confused by these ands which you've seen in JavaScript, which is like if thing and other thing, right? This is like a Boolean expression where you're trying to figure out like whether it's truthy or falsy. This is not going to check everything, but the order of operations is pretty similar. It's going to run foo, and if that exits with exit status 0, then it will continue and do the bar. If it exits with any other exit status higher than 0, it'll fail and not do the and. So we'll see that we got all these, but if I just put get blah here, that's not a real command. But even if I just put get, it won't do those later things because the exit status isn't good. So you can do things like try to run a get's a horrible example for this because it does that waiting thing. Let's do brew remove everything. right? And echo done, right? So it's not going to echo done because remove everything isn't a thing. But if I do like brew list and echo done, then it'll echo done at the end there.
And
So
that's because it's returning an exit.
that's because it's not really a return. It's different from a return, but essentially, yes, it's exiting with the exit status 0, which means it was successful. Yeah. So in our process here, we're going to want to, node will exit 0 by default. So we're going to say explicitly like bail out and fail. Yeah. So again, if we run our log command, we get this usage. And then if we run log list, it does nothing, right? Because it got into here.
But does the exit command have to be 1 to be any number besides
There's other numbers higher than 1 that represent different kinds of failures. I actually don't have them memorized. I only use 0 and 1, but I'm sure that there's a way to communicate more detail about why you failed within your exit status. But the basics are 0 is good, anything higher is bad. Okay. So now we want to, let's do append first because we don't even have a log. So we're going to say append, which is a function that doesn't exist yet, and we'll send in, let's call this the message. And we'll append the message. And here we'll call list, and we don't need to send anything to it. But where am I going to get these functions from? I'm going to define them in another file.
Are you recording here?
Yeah, I think so. Yep, I'm recording. Okay, so let's make those files, list and append.js. So now we have those two files. I used that bash brace expansion here from a previous lecture. So now we have a couple of files here. We've got append and list. These are going to be just required by this file, so they don't need to be made executable or be given this shebang or anything. They're just going to be sucked in by node. They're not going to be executed directly. So we can do this like we normally do by just putting module exports equals some function. In the case of list, we don't take any arguments. But in the case of, here, let's go and do this. Oh, okay, let's just quit PyCharm instead. Okay, let's do this. There we go. Cool, and then we get append down here. All right, in the case of append, we're gonna take a message. And for now, I'm just gonna log would append message and console.log would list, just because that's what they would do if they worked. So /log, oops, /log list, cool, and append. Oh my god, great.
Oh,
Yeah,
songs are cute.
songs are cute too. Great, cool. Everybody following me so far? Any questions about up until this point? And about how this is all plugged together up here?
Oh,
Let's dig into it.
yeah. How did the I missed where the functions are. Okay, never mind.
Yeah, so I required them here, and then I just did a check for the command, and I ran this one or this one. Otherwise, I exit with the print status. Yeah, cool. All right, so let's do append because we don't even have a log yet. So let's look at append, and we're going to probably use fs here. And we're going to do node append to file because I don't know how to do that. How do you append to a file? So these are some Stack Overflow links. I could go there, but I see the file system documentation down here, and I know that's good. So I'm going to go here. And I'm going to look for append. And I'm going to use append file sync, so we don't have to worry about callbacks because we're in phase 1. We're doing synchronous code. So I'm going to use this one here. So that looks easy enough. I just give it the file and the text I want to append, and I don't think I need to do any options. So I'm going to do append file sync, and then I'm not sure where the file's going to go, but I know my data is going to be this message. So where should where's the file we're going to log to? I would normally just put this in here, but I know I'm going to need to share this information. So I'll get to that actually. For now, we're going to do const log file path equals, and I'm just going to use the _ dir name. Is everybody familiar with this? No?
Familiarize me again.
Yeah, in Node, every file that you're in has the special variable that represents the full path to the directory the current file is in. Right? So here's our directory. I'm in the append file, which is here. If I say this is going to represent this same directory here, this giant path here. Yeah? So I'm going to do that, and then I'm going to do plus a slash, and we'll do messages.log or something like that. Yeah. So let's just log that before we, actually, let's see if it works. Let's see if it works. Log append, I like ice cream. Ah. Y'all are supposed to be pairing with me on this. Cool, let's try it again. Okay, so no return value, but let's see, do we have a messages log now? We do, and I want to cat that, and that's the only line in it. And now I've catted this file, and I'm noticing it printed this out, but my prompt started on the same line, which tells me this file does not have a new line character at the end, which tells me I probably need to add a new line character here, so because I want to append a line, not just any text, right? So let's clear out the messages file and run the log again. And now we'll cat the messages log, and there we go. So if I log a few things, we got a bunch of things being appended to this file here. Okay, and now we just want to read that for the list. So I'm going to do read file sync up here. I also need fs. And then I need this log file again, and I could just copy and paste it up here, but that would be not very dry. That would mean if I needed to change this information, I'd have to go to multiple places for it. So now I'm thinking, now let me, actually, I'm gonna let it work. I'm gonna get it to work, and then I'm gonna figure out how to dry it up. But keep in mind, in my workflow, I probably wouldn't even do this. I probably would start to refactor right now, but that would be me jumping ahead from a lot of experience. So I'm gonna get it to work with some duplication, and then we'll dry it up. So we want to read file sync. And it's synchronous, so we can get log lines, or whatever we want to call it. And I'm actually just going to console log everything that's in this file. So let's see if that works. .log list. Oh, it's a buffer. I forgot, so I have to read that buffer by calling toString. There might be another way to read this buffer, but I'm going to call it toString. There we go. Okay, so we can say append who likes cheese, and then list, and we've got that on the bottom there. And I'm getting an extra new line here, and that's because I'm using console log. So I'm actually going to use process.standardout.print, I think. I don't know if that works. I'm going to jump in a node console. It's not print. What's it called? Write. Is there a log? No. What's on here? I think write is what I want. Let's try it. So console log writes to standard out, but it actually appends a new line to it as well. So there we go. So now there's no extra new line. So this process standard out write, this is actually just an alternate way of writing to standard out. So in Node, you see the difference between that and console log. Console log returns undefined instead of true, and it also puts a new line. So it's almost as if I had put A with a new line here. Yeah? So console log wraps around standard out right. So I'm using the lower level API to write to standard out so that I can avoid having this new line character that comes from console log. Does that make sense? Any questions about that? I'm seeing a little bit of furrowed eyebrows. I think I've lost some of you.
I feel like it's a bit abstract.
Which part? Just the process standard out, right? Okay. I'll talk a little bit about that then. So the node console has all these functions on it, right? But there's actually a new console. There's actually a console constructor, and you can pass in 2 different write streams. So write streams are just like, they're essentially pipes. They're essentially like a one-way place to send text. They're a text pipe. They're like a fax number, right? You can send text down them and they'll go somewhere, right? When I run node the CLI, node the REPL, the standard out write stream is just my terminal, right? So if I do process.standardout.write, it ends up coming to my terminal, right? That's because, so when you type ls to list a directory, the ls program has a standard out write stream, and that goes to your terminal. So it reads the files and constructs that ls text and sends it to standard out, right? There's also a standard error, which is a place where you can write errors. And the reason there's 2 different streams is so that you can like pipe the output of a program somewhere else, and the errors can be read in a different stream. So console.log just writes to standard out. So same thing, if I do console log, it writes to standard out, but it also puts a new line character at the end. So internally inside of console log, it's calling this function, but adding a new line to the end of it. So that's peeking into a little bit of the like under workings of how console log works. And that's really all you need to know, is that console log wraps around one of these objects. Standard out or standard error are, what are they called? It's a write stream. So this is getting a little more technical around bash and processes that I intended to go in this talk. So I'm going to keep going past this. If you want to know more about how console log writes to the standard out write stream, there's some Google for that kind of thing, and you'll find some good blog posts, or I can talk about it in office hours another day. But I just want you to know that I'm doing this so I can avoid the new line character. So when we go log list, we get a nice output that doesn't have an extra new line. All right, so this whole thing's supposed to be about testing, and we haven't done anything about testing. But now we have a decent program here that is going to let me append something new to the end of my log file and then read that log file and print it out. So does the functionality of the app that we're, like this is, let's call this V1, it's successful, it's working the way we want, but now we want to write some tests. Yeah? So I'm going to actually check some stuff in. So I'm actually going to echo messages.log, and oh, it's already ignored. But anyway, I would normally append this to my get_ignore file so that when I add everything like this, I'm not checking in that log file. I'm just checking in my source code and my package.json and the get_ignore file. So then I still have a messages log, but Git is ignoring that file. So let's commit this as our initial commit. And now we're going to install Mocha and Chai. We'll probably install Synon at some point, but we'll get there. We'll get there if we get there. Is it called Synon? I don't know.
It's like looking at the,
How do you pronounce all these libraries?
there's like multiple pronunciations.
Yeah,
but-
yeah. All right, so
Yeah.
we can really put our tests anywhere. Mocha recommends that you make a test directory and that you put your tests in there, because that's what it'll default. That's where it will look for test files by default. So we'll do that, but we could have put them anywhere. And I'll do list.test.js and append.test.js. And we will make some tests. So here we have append, and here we have the append test. So let's take a look at this. And part of this talk is going to be about looking at some code and figuring out how to refactor it so that it's more testable. And we're going to end up having to do that here. But let's do what we can until we have to. So we're going to say describe, append. It should take a message and write it and append it to the log file. Okay, so let's write some pseudocode here. So what I probably could do is I need to require list or append. And then let's see, I could empty the log file and then call append and then read the log file to see if this is working the way I want it to. That's what I think I'm gonna do. We'll see how that works out. And I still have this problem where I don't know where this log file is. If I'm going too fast or you get stuck or you have questions, I want you to feel very free to interrupt me because I keep seeing a couple people look a little confused. So I want you to feel free to ask questions or stop me if I'm going too fast. So any questions? All right. So if I was to empty the log file, right, I would probably do something like write file sync the log file path, which I don't have access to, and then I would just empty it out. Right? But I don't have this. And so I need to either export this or move it somewhere else. And given the fact that my list also has this code I want to refactor anyway, I think I'm going to do this to refactor it. I'm going to go into my main log script and I'm going to put the log file in here. And when I call list and append, the first argument will now be the log file that I'm talking about. So I'm injecting the information that I want these functions to have so that log file path now comes in as the first argument for list, and for append it also comes in as the first argument before message. Yes. Got it. Okay. So here are these two files, list and append. They look like this, right? They both have this duplicate code log file path, which goes to the same place. I could have a bug if I did something like that, right? It wouldn't work. It would be looking at different places, right? So I want these to be in the same place, right? So there's a couple of options. I could put them in another file and require that file from both of these files, and that's one way to share code. But what I want to do is actually tell the append function and the list function what file we're talking about. That way they're more universal. They get told what file and whatever other information they need, right? So instead of this method, the list method, knowing about this, I'm going to get rid of it. And I'm going to require whoever to pass in the log file path. So does that switch make sense? Going from having our own private variable that's defined in this file to changing the function we're exporting to require that it be given that information at call time.
So where's that going to be defined?
Well, technically it's declared here, but it's going to be given. Whoever requires the list file gets this function. And then calling list requires that you tell it what log file you're talking about. Yeah? So now the list functions, the usage used to just be like this. You just call list. But now it's list with, some path to a file .log, right?
And so you have to manually you have to tell the function every time you call the function which exactly path you're going to transfer
Yeah.
the function.
Yeah, the list function now requires that you tell it where the file is that it's supposed to be reading and logging. Right? And the reason I'm doing that is because I want to do the same thing up here where the append function, I no longer want to give the append function the append function as it's written here is married to this path. It's locked in to this variable. It's not changeable by anyone who's required the append function. The append function only works for this path. And so I'm making it a little more versatile by taking that constant away and putting it as an argument. So now anyone who calls append can specify what log file we want to append to. Does that switch make sense? So now if I look at how I'm calling this thing, right, I have to tell it what log file. Before I was just calling list and message, and it was working because both list and message privately knew which log file, separately knew which log file we were talking about, right? But now the responsibility for knowing what log file we're talking about has been moved to the caller of these functions. And so I'm defining that log file up here in my higher level script, right? In my step up script, one level up. And now when I call list and append, it does that. So let's make sure that still works. If I call /log list and append another new thing, it's still working, right? And if I just change to messages to, I can say append should go to messages to also, and then I list, whoa, and it's going to a different log file, which is now called messages to. And if we cat messages to, we'll see both of these. Oh man, somebody who just connected needs to mute. Thank you. Okay. I'm not muted. Cool. Go away. All right. So did everyone see how I switched from the messages log file to the messages to log file? By just changing this, both of these, the list and the append function, still function, still work, and write to a different place.
And then so if you so if the path is going to be passed into the function, like what the function here have to write the path, why do you send it to that at the top?
Because I need to pass it. So the question was, if list and append now take log file path as an argument, why do I have to declare it at the top? Right? Because that's where this variable is being defined. Right? If I didn't have this, does anyone know what error I would get? Any guesses what error you're going to get?
Reference error?
It's going to be a reference error. Yeah, it's going to be reference error, log file path is not defined, right? Because we have to tell it what file, right? So we need to declare. So this script is now the decider of where the log file was used to be shared independently between append and list, right? But now I've moved that responsibility to the caller, to the higher level script. So we define the log file there once instead of twice, and that cascades down through passing arguments, right? That makes sense? Okay. So this is going to make testing easier because when I look at the tests for append, I can now give it, when I call append here, I can now give it whatever log file path I want, test log line 1. And I get to decide inside my test what log file I want to use. So I can use a custom log file inside of my test now that I've moved the responsibility of knowing which log file to write to out of the function I'm testing up into a higher level. So now my test gets to also decide what log file I'm talking about. So for the purposes of testing, I'm going to make a temp directory. And in here, I'm going to make my log file __ dir name plus go up one directory, right? Because I'm in test here, so I want to go up one directory and then down into temp. So I'm going to be like test log, how about just test dash messages.log. Right? So now the log file, when I run my tests to test these functions, will be a different log file. I didn't put what?
The log file path.
Oh, thank you. Thank you. I didn't put TMP. Thank you. Cool. So let's just log this inside the test so you can see that this path worked out. So before we actually write this test, I'm going to run Mocha. And this is the path, right? I'm in this annoyingly long lecture name directory. I apologize. Let's just fix. Oh, anyway, I hope you can see that. Does this path make sense? This is just one long directory name. So, but you can see that we log /example/test .. Yeah? So let's see if that works. Let's try emptying the log file and then calling append and then reading the log file. And then we'll expect log lines to equal, I don't actually know. Oh, well, I do know. It's going to be with a new line.
You have the required.
Thank you. Yes, we also need to require FS. Oh yeah, I forgot again that this needs to be toString because it returns a buffer. There we go. Okay, so and then also we can look inside of temp test log lines and see that that was there. Yes. Yeah, it does. It uses append right here. Got it. So this is something that I could probably move. I'll probably move out of this test and share among many tests because this right here is just picking a log file and then emptying it out in case it already exists. And that's just sort of some setup code. So let's move this to a before each. And then let's move this up here. So this will just be the log file I use for all my tests. And before each, we're going to empty the log file by writing an empty string to it. And then inside of our test, we just call append, and then we read the log file, and we assert what's in it. Yep. So let's try this. And it still works. So now we can write another test that tests we'll just test it multiple times. So I'll put a couple of these in here. And now I'm going to make sure that this just make this a little easier to read with some multi-line strings. That should be our output. Cool. So whenever I write tests and they just pass, I try to make sure that I'm breaking them, right? So let's go into our apply method and take out the meat. So now it shouldn't work, right? It has nothing in it. So let's see, and we got an error, right? Maybe we can append just the first character of the message and see how things error, right? So we got TTT and we expected to get that. So we know our tests are testing the right thing now. Okay. So this is one way to test what our script is doing. It's actually testing that the list function and the append, we haven't written functions for tests for lists, but I think you can imagine how we'll write tests for lists. It's very similar. Does anyone want to see that, how we write tests for the list function? And if it's different, okay, let's do it. It's going to be very similar to this, so I'm just going to copy all this over, but it's going to be a list instead of append. And we'll share. Normally I would share this code, but for the sake of time, I'm just going to copy it over where we have the same log file, and we're going to empty out that log file. But actually, let's not start with an empty log file. Let's just put some stuff directly in the log file. Okay, so we've got some, we're just going to write directly to our log file, and write is not going to append, it's going to overwrite that file, right? So we're going to start the tests for list with the log file containing some stuff already. So then we'll say it should read and print the log file, the whole log file. And it's very similar to the last part of this, where we're just going to read the file and make sure, or we're not just going to read the file. We are going to say, oh, yes. This is great. Thank you for asking for this, because I almost forgot. Okay, so we're going to say list. Path must be a string or a buffer. What did I do? Inside of list line 5, it doesn't like this log file path. Oh yeah, I've got to pass log file path to list, right? So let's try this again. And the test passes and it prints out the log files, like list is writing to standard out. So how do we test this? It's actually really difficult to test this because we don't have access to standard out. We're not controlling standard out, right? So there's a couple of things we could do. We could do what we did before, which was instead of the list function knowing where it's supposed to write this to, we could give it the write stream that we want it to write to. So in the log, in list, we're going to pass in process.standardout. So we're giving the dependency to list that it's going to use to write. So let's make sure it still works. We'll go log list. Oops. And that still works. Oh, I even left this as the old messages. Right? We can still append and list with this refactoring where I moved, right? I moved this code. I moved the thing we're writing to outside of the function. So now in our test, we can pass in our own write stream. So let me figure out how to make a node write stream. I just want like an in-memory stream. I think I can just make a new stream. Let's try it out. All right, well, that's not going to work for me. So what I'm going to do is I'm actually not going to make a stream at all. I'm going to make a fake stream. Because the only thing that our function calls is this write function, right? Up here, we take the write stream and we just call write. So I'm creating an object that just happens to have a write function on it. And it's a fake stream. So in production, right, in the environment, we pass in a node object that when you call the write function, prints it out to our terminal, right? So list takes the write stream and basically, and we can see still actually is able to write to that stream, right? But in test, we're gonna pass it a fake object. It's not a fake object, but it's a fake stream that only has the function that we expect the list function to use. And so now we can have a fake log file. We'll just call this log lines equals a string. And we'll just say log lines, it has to be a let because we're going to change it. Log lines plus equals message. And then we can expect log lines to equal whatever it is we put in here. So let's copy this. Little complex. Let's stop and dig into this if y'all have questions about this. Yes, Sal. Okay. All right. So let's back up then. We're trying to test the list function, okay? The list function just takes the path to a log file, reads it, and then passes that content of the file to the write function on the write stream that we were given. This is not, you don't even care this is a write stream, this is just any stream, right? So this happens to be the stream that comes to our terminal. Does that part make sense so far? Just what this function's doing right now?
It finds the information and writes it to it.
Yeah, it reads the file for the path it's given, gets that string, and passes that string to the write function on whatever stream it was given, right? So is everybody on the same page of just what this is doing? No?
I guess I'm just hung up on the word stream. I mean, I understand that it's like, it's doing the write function from an object with a bunch of different.
So here, let me try to explain streams for just a second. If I just do ls, right? This text comes out to my terminal, right? If I do ls pipe subble, which is Sublime, my editor, it sends that text to my editor, right? So that the text that comes out of ls goes across what's called a stream. And normally, all streams are connected to your terminal when you run a command. So the standard output of these commands comes to my terminal. But if I want to redirect that output, I can put it in a file, right? And now that file had the output of the ls command. If I can, again, send it to my editor, I can send this wherever I want. So you run a Unix command and it has standard output, which is a stream of text, and you can pipe that around. You can send it to another command. You can send it to your editor. But by default, it gets sent to your screen, right? So just like our log command, I can do .log list, right? And I can pipe this to Sublime, and it comes here, right? So there's this concept of shell commands have a sort of standard output where they're just shoveling text into, right? And the reason it's a stream is because it's not just like A, run the program, B, give me the text. It's actually can be a living process, right? So for example, if I do find on my entire computer, it's streaming the results. It didn't get the results and print them. It is over time, sort of, you can think about it in a loop writing using console log, right? You're looping and you're log, right? You're streaming information out of your command, right? So if I want to find slash and then pipe grep, look for anything that contains the word frog, this is going to find every path on my file system, and we'll look for anyone that has frog. It's sitting here, and it's streaming all of that data we just saw, sending it to grep, and grep is only printing things when there's an error, and we'll talk about that later. The content you're seeing here is a different stream for errors, right? So let's ignore that. I'll get rid of the errors, or maybe. Oh yeah, this needs to be here. Ignore this part because it's really it's beyond answering this question. But I these errors because it's a bad example. So fine. So let's look for any log line that contains the letter P. Now we got a bunch of them. How about app? It should be a little slower, right? But if I look for something that doesn't exist, you're not going to see any output, because grep is listening to this stream, and every time the previous command writes to it, it does its check and optionally prints. But it's a living process. This find command and the grep command are running at the same time, and they're connected together with this stream, with this pipe, right? So that's more complicated than anything we're doing in this script. We're just writing and leaving, right? We can pretend that we're doing something, writing some output and quitting, and that those are atomic options, and that there isn't this open stream that has activity and events and a lifetime, right? Ours isn't that complicated, but we're calling it a stream because every Unix program that runs has an output stream so that it can sit there, right? You've run like Express servers before, and you see that every time you visit your Express server, it outputs some information, right? That's a stream that your Express server is writing to, right? Does that clarify things a bit?
So the output of the stream is only in text, right?
That's technically not true, but for the sake of learning how this stuff works, let's just say they're text all the time. You can send binary data and all kinds of information. You can send different stuff, but text is very common, especially with all the commands in the terminal. Humans only understand text, so we're just going to pipe text around, right? Cool. So let's say so when I do log list, it writes to the standard out write stream, which I could pipe to grep and grep for just new, right? So it's a stream just like the other one, but that's why we're passing in the stream we want it to print. Does that make sense?
So we're creating a stream in this test.
So in production, in normal mode, we just do standard out, which sends it to wherever the caller wants it to go, by default the terminal. But in our test, we're going to pass in a fake stream. And if we look at these side by side, list just takes whatever you gave it and calls the write function. Blindly assumes there's a write function and calls it. So we're going to make an object that just has a write function. And what that object is going to do is take whatever string was given to it and append it to this string. So we're kind of pretending to be a stream, right? You can call write over and over and over, and we'll just take whatever you give us and we'll shovel it onto this buffer, this string, right? And then we will assert whether or not that's correct. Whether or not we wrote this to the file, we call list reads the file, and if it read the successful content that we put in the file and called write with that content, we should see it's actually only going to call write once. So let's just call this output, and we'll just say we don't even have to do this appending part. It's simpler, right? Whatever was passed to write gets stored in output, so that output can be tested here. Yes, Sal?
What is structure of the fake stream to the total object and passing the function as an element instead of like calling the function of itself? I don't understand structure right here.
Okay. I wish we could have recorded that question, because I'm not sure I can repeat it, because there was a couple of ways you asked that question that seemed a little like the wording was a little off, right? So let's dig into this, right? So normally I'm passing in process.standardout. If we look at that, process.standardout is an object, and it has a write function on it, and if I call it, it writes to standard out, right? So what we've created is fake stream. So if I make fake stream looks a lot like oh, thank you. Fake stream is an object that has a write function, just like standard out is an object that has a write function. It just happens to have a ton other stuff on it, right? So I'm making a fake version of this stream. And I'm not going to call write right now. I'm not going to call anything. That's the job of the thing that I'm testing. I'm going to give it a fake stream, and it's going to call write, right? So that's what I'm testing, is that if I give this thing an object with a write function, will it call that write function, and will it call it with the correct content? Because if that's true, then when I pass in standard out, it will call write on standard out, and that output, which is the correct output, will go to the output of the script, of the standard out of the script. So Sal, can you ask that question again just to see if we have some additional clarity?
Yeah, I was just wondering why the structure as an object, and then, you know, and then the function is the element.
So the question was, why did I structure fake stream as an object and make write a function of that object? And it's because this mimics what the standard out object looks like. It's an object with a property called write. That's a function that you can call to write to that stream. So this is a stream that is bullshit, and it has a write function. And if you call it, it just stores that in a local variable. So again, if I call fake stream.write, oh, I would need an output to exist. So if I call fake stream.write hello there, now output should equal hello there. Does that make sense, Sal? Sweet. Okay, so let's run our test. Thanks. I must have typed something in there. Okay, so it looks like it passes. So let's look at that, right? If I pass whatever text I go here, or excuse me, whatever text goes here gets written to the log file. Remember, our log file is in temp here, so we can see that that worked. That content got in there. And then I make a fake stream, and I call list, and I say, hey, here's the log file, and here's the streams you should write to. So list reads the file, gets the content, and sends that to the write function, which we intercept and store in a local variable. And we can assert now that the file we created that had this content was read successfully and sent to the write output successfully.
So couldn't you have just, instead of like making a fake stream, couldn't you have just pointed the list to the temporary test file and then said expect it to equal the for each content and tested it that way as well?
What do you mean point it at the test file?
So like right now you have a list log file path.
Yep.
When you're moving it down there in the test, couldn't you just tell it to, instead of testing the log file path, to test the temporary file and see?
This is the temporary file. This is the path to the temporary file. That this variable contains the path to our test messages log file. So the same way that I'm using that variable to write before my test starts, that same string, that same file path is being given to list and used by read files, or given to read file sync to read that exact same file.
Yeah. Okay.
Does that clarify? Yeah, cool. So this is just a way to do what is commonly called dependency injection. So this function, the only dependency that it's not given is the FS one. It depends on FS being there and being requirable and working, but it doesn't know where its log file is going to be, and it doesn't know what stream it's going to write to. But we give it those things, and then it reads the file and writes it to that stream. So because we did that, we had to restructure our main script a little bit. I had to put the log file in my main script and pass it down, and I also needed to pass standard out down so that I could inject the dependencies this function needs. And because I've refactored in that way, the new version is much more testable because I can give it whatever file I want, so I'm not clobbering whatever real file this code might be using. Not real file, but whatever, like production or main file, or like, you know, when we're running this actually as our script, right? And then I can also, oh, it's the wrong test file. I can also make a fake dependency that works as I expect. So I'm implicitly testing some things here, right? I'm implicitly testing that our list function calls the write function on the stream that it's given. That's like being objectively tested here. right? Because if I didn't give it a right function, if I gave it a right x function, it would get an error saying right's not a function on that string. So it needs to be shaped correctly. So this is something you should consider as you're writing code, is that if there are dependencies in your code that you can consider moving them to, consider dropping that dependency, dropping that explicit dependency in favor of being given that dependency, right? So previously we had log file, the log file path defined here, and then we decided let's not be fixed to that dependency, and we'll require that we be given that information. So that in this case, so that it's more testable, right? Because before we weren't able to test the list or the append function without messing up the file we want to use when we run for the real world, right? But so in our test environment, we want an ability to override what our normal application is using so that we can use a temporary file. So that my main command still has the data, still has the information I care about. This is my production data, right? This is my normal data. Whereas the files that are in temp, the data that's in the test log, this is coming depending on the test. If I run a different test, if I run the append, it uses that same file and it's got different stuff in it, right? So this is a throwaway file where the other one is important.
So you just kind of fold it apart so it's more testable.
So it's more modular and more testable, yeah. And that's all I got. I'm going to save this code somewhere and link it in the comments of the YouTube video so you can play around with it. I hope that was helpful. Thanks, everyone.
Thank you.